In chemical engineering, we are often called upon to analyze experimental data and take a look at how models that we use to describe physical and chemical properties, how well they fit data that we collect in the laboratory. And presenting our data in graphical format is always something that you should be able to do well and have it look like it's a professional quality. And so that's what we're going to take a look at in this session. We're going to be working with a Excel file, and you may wish to open it up now. It's called Developing Professional Graphs Worksheet.xlsx, and it's in this learning module. And I'll be working with this particular spreadsheet and showing you how to generate good quality graphs. You might want to pause right now and open up that file so that you can take a look. So let's see what we're going to be doing in this session. I have this little experiment that I did. It's actually a model of an experiment, but it is something that we could encounter as chemical engineers. Imagine having a rigid vessel made out of metal, perhaps, that has a fixed volume of 1.0 liters. And this vessel, we have the ability to open and close it so that air can travel in or travel out, depending on what the pressure inside and outside might be. And this vessel has a heater on it. And the experiment we're going to do, or actually the virtual experiment we're going to do, is we're going to start our experiment where the temperature and pressure are at 20 degrees Celsius and 1 atmosphere, respectively. And then we're going to isolate this vessel from the outside air, and we're going to turn on a heater, and that heater will allow this temperature to increase. And when we reach certain temperature points, we'll record the pressure that's taken with this pressure indicator at these various temperatures. And so our experiment, what we did was we collected data from 20 degrees C all the way up to 100, and we measured the pressure. Actually, in my experiment, I took 5 different data points at each temperature. So the pressure that we're measuring here is the average of those 5 points for each of those temperatures. And we're going to be using an ideal gas law in just a moment. And if you recall that the pressure times the volume will equal the number of moles times the ideal gas constant times the temperature, PV equals nRT. And we're going to test whether or not this model is an accurate prediction of our experimental data. I talked about this average pressure that we collected. We had 5 separate experiments with 5 different pressure measurements. I'm not going to show you today how to generate what we call error bars, but this tells us how uncertain we are of the actual pressure measurement based on 5 separate measurements. And so we're going to be looking at how we can plot these error bars along with our pressures. And we're also going to compare it with a ideal gas law model. When it's all said and done, we're going to end up generating a graph that looks like this. Here I have plotted on the y-axis the pressure and on the x-axis the temperature. In this experiment, I changed the temperature by changing the heat that goes into it, the heater. So that is my independent variable. It's the variable that I controlled. My dependent variable is pressure. I did not adjust pressure. I did not control pressure. All I did was measure the pressure. So generally, we will plot our dependent variables on the y-axis and our independent variable on the x-axis. Let's see what else we were able to look at. These dots or circles on my graph are my experimental values. These are the average of 5 independent measurements of pressure. Also with these are the error bars. This is the uncertainty I have of my data. When I collected the 5 different measurements, I was getting different values of pressure even though the temperature was the same. And so we will look at how to calculate what these error bars are in the future, but we'll just use the values for right now. So we plotted those error bars on there at the same time. Lastly, this line is my ideal gas law prediction. So my model I use is a solid line, whereas my experimental data I plot as individual data points, and we'll show how you do that. And I have various different labels on there so that the reader can figure out exactly what's going on in this particular experiment. After opening up the spreadsheet, you'll see that we have similar information that I showed in the PowerPoint given to us in the spreadsheet. And this is what we're going to be working with and how to generate this graph that we desire. There's a tab called Chart 1. Our goal is to be able to generate one that looks just like this. And we'll go step by step on how to create it. In my spreadsheet, I've given some of the information about the vessel volume, the initial temperature, the initial pressure, ideal gas constant. And here I calculated the initial number of moles inside my vessel. And that's given by using the rearranging the ideal gas law that and the number of moles will equal PV over RT. So to calculate that, we can see that I took the C6, which is my pressure, times C4, which is my volume, divided by my ideal gas constant, 0.08206, and the temperature. Remember, in ideal gas law, you have to use the absolute temperature. So if my temperature is in Celsius, I have to add 273.15 to that in order to put that into the absolute Kelvin scale. Here are my temperatures and my average pressures. And these are the numbers for the error bars. Notice that at that initial condition, my error bar is 0. And that's because when I did my experiment every time, I virtually opened up my vessel to the atmosphere so the pressure was equal to the atmospheric pressure, which was 1 atmosphere, and the temperature was at 20 degrees C. So all 5 times I start at exactly 1 atmosphere and 20 degrees C. So I don't have any error in that initial measurement. But as that temperature increases, then I start seeing different values of the pressure depending on which experiment I'm running. And because of that, we get these error bars. And we'll learn how to calculate those at a future time. Also, ahead of time, I created this little item in my spreadsheet where the various different things I'm going to be using in my plot, the variable 1 name and the variable 2 name, the y-axis title, the x-axis title, chart title, I put these in cells. And I like doing this because it's a lot easier to change a title or a variable name in the cell rather than on the plot itself. And so it's very convenient to have these already pre-prepared for you. And you'll learn as you go along that this might be something that you'd want to adopt as well. But anyhow, let's get started. First, we're going to create a graph. And what we want to do is plot on my y-axis the pressure of my gases and on my x-axis the temperature. You might have your own way of creating a chart. But I'm going to show you the way that I do all my charts, because as you get more sophisticated, you'll find that doing it in this fashion allows you a lot more flexibility than what you're currently using. So the type of chart that we're going to create is going to be an XY scatter plot. Almost all your plots that you're going to encounter are XY scatters. And so get used to putting that in as your default. So to do that, we go to our Insert tab in the menu, and we have this little box for all the charts. And I'll just click Scatter Plot, and I'm going to select the one with just data points. Right now, it doesn't know what variables are my X's or Y's, and so it's just blank at the present time. So now what I want to do is select data. So in the design mode, you can see that select data is in the menu bar. Many times I just right click on there on this and put in select data. And I'm going to click add. Okay. And my series name, I'm going to just click on my pressure experimental. I already had that in my label box there. And my X values are my temperature, so I'm going to select that with my mouse. And my Y values, going to select my experimental average pressures and click OK. So here we have just this plot of my data points. On my x-axis is temperature, my y-axis is pressure. Now it goes from 0 to 1.4 for the pressure, but I know that, well, I only want to look at from 0.8 to 1.4. And so I can click on that y-axis, make it a left click, and then right click. And what I want to do is click on Format Axis. And the options tells us a minimum and a maximum. I'm going to make that 0.8 for now. And now it kind of expands my y-axis scale. This makes it easier to see things a little clearly. Now, we talked about these error bars. Going to show you how to put these on this cell. Okay. And so I'm going to take my mouse and just right click on that data. You see that it highlights all the data points. And I'm going to hit the design button. I'm going to go to add chart element. And notice it says error bars right here. And I'm going to initially select, and we can go standard error, we can go percentage, doesn't matter. We're going to modify it anyhow. I'm going to go with percentage right now. And notice it put these lines on my data points here. And this is what we're going to do. We're going to modify it. We're going to tell it that it's actually going to be these error bars given here. So the first thing I'm going to do is zoom in a little tighter so I can see what I'm doing. And I'm going to click on the Y error bars. And it comes up with this format error bars here. And it has it selected as a percentage, 5%. What I want to do is change it to custom. And I'm going to specify the value. And it comes up with this menu, a positive error value and a negative. In our case, the positive and negative distance is the same. So I'm going to click on this up arrow and select the error bar. And the negative, I'm going to select the same data and click OK. So what it's doing is drawing a line from the data point plus that error and the data point minus that error. Now, as far as I know, I had no error in the value of my temperature. I somehow was be able to get that exactly the value I wanted. So I want those error bars removed. And so I just clicked on those. And right now I'm on my horizontal error bar. What I'm going to first say the end style is no cap. And then the fixed value, just going to make it exactly 0. So essentially what it did was remove the X error bars off of my chart. And now I can see I got my data points where with their higher and lower error bar values. Now what I want to do is include the model of the ideal gas law and see how well that fits. And what I did was this. Our pressure is equal to the number of moles times R times the temperature in Kelvin divided by the volume. Now the N, R, and V are fixed because we start off with the same conditions. The volume doesn't change. The ideal gas constant certainly doesn't change. And the number of moles is the same at the beginning of every experiment. And so if I have a range of temperatures, I can come up with a prediction of what the ideal gas law would be. If I know how many moles of gas are in my vessel, I calculated that already at 0.0416. My vessel volume is always 1 liter. And as I change my temperature, my pressure will vary. So I put in a couple of temperatures. Since this is an equation of a straight line, I don't need that many points. I actually theoretically only need 2 points, but I'm going to put in 3. I put in a low temperature, a medium temperature, and a high temperature. And I use this ideal gas law to calculate what that pressure would be. So it looks at the temperature, looks at the volume, the number of moles, looks at our temperature, converts that into Celsius, calculates our pressure. So here I have the pressure using ideal gas law at these 3 different temperatures, knowing what the initial moles was. So what I want to do is to plot the model on my data. Now, convention is this. If you have experimental data, you plot them as data points. If you have models, we generally draw them as smooth lines or curves if it has curvature. So I'm going to click on my little chart, go to Design, select Data. Now I'm going to hit Add. The series name is my pressure. IGL stands for ideal gas law. My X values are these 3 numbers. My Y values are the calculated pressures using ideal gas law model. And I'll click OK and click OK. Now what Excel does is plots those 3 numbers as data points, but what I want to do is convert that into a line. So I just clicked on the data points and I'm going to reformat that. One way we can do it that's kind of easy is if we just go to our Format tab, and if you look here, it lists everything that's on there. So right now what I want to format is my series pressure, ideal gas law, and click Format Selection. So we end up with this little menu here. And I'm going to click on the Fill and Line option here. Right now it has no line selected. I'm going to click a solid line. The color I want is black. Okay. I can change the color if I wanted. The width is 2 points. It may put in a much thinner line on yours, but you can change the width. That will change the thickness of the line to be 2 points. And even though this is a straight line, I'm going to hit smooth line. Because in the future, when you draw a model that has curvature to it, you want it to draw smooth curves through the various points you use to generate that curve. Now, we don't want to use experimental markers for a model. So if I go to the marker and click on marker options, I'll click none, and that will remove those. So here is my chart right now. It's got the data and the model plotted on there, got my error bars. Now it's just a matter of how do we get this chart to look good? And what can we do to make it look professional? Many times we often don't want to display the grid lines in that the Excel automatically puts on there. And so what I can do is just uncheck grid lines just from here and they disappear. But we want to make sure our axes are have the proper labels and other things that might be interesting for us. So we can do a couple things now. One is we want to put the title of our x-axis. So I can go to my chart element and click axis titles. And I can go out. I want primary horizontal and primary vertical. Notice that it put them there already. Okay. My axis title for my x-axis. This is where using the title in the cell is nice, as we can just put our cursor up here and just say equals. And I can click on my x-axis title right here and hit enter. Notice it puts it right down here. If I want to change that axis title, all I have to do is just go right here. I make a change. Let's say I, you know, wanted to put the change to be vessel, and I can go look down. It automatically updated this. Again, for my y-axis, I click on that just to get that highlighted and type equals, and I'll put pressure here. And it included the pressure on my chart. Okay, so we want to add a couple elements. One is we want to identify that this line going through my data point is actually a model. I want to say it's the ideal gas law model for this. And we can do it a couple ways. You can do it with a legend, but I'm going to show you how to do it with what we call these data callout boxes, where I have ideal gas law for this line. And I also put this as my starting point for each experiment. I'll show you how that's done. The first thing we're going to do is let's just click on that ideal gas law prediction. You notice that I have 1, 2, and 3 points. The reason why I put 3 points is I want to use this intermediate point to be a data call out. Okay, so I'm going to just click on that once more. And so now that it is the only one of the 3 highlighted. And then I'm going to right click on that point and it has add data label. Don't click yet. We want to go to where the arrow is and say add data callout. Not data label, but callout. and I clicked on it. Okay, I'm going to click on it, and I'm just going to drag it out of the way a little bit. So actually what it did was it put the temperature and the pressure there on it. Okay. And really what I wanted to say is make this the label that I've called the ideal gas law prediction. So I can type in an equal sign and just click ideal gas law prediction and hit enter. And it automatically changed it. And make it stretch it out a little bit so it's all in one little box like that. We'll adjust it later. So I have this data label call out for the model. And I also want to indicate that this data point here, I'm going to just single click on him and right click on it now to add data label and then data call out. Whoops, didn't mean to drag my thing here. Here, I'll drag it down now. And then I'm just going to hit the equals key and hit that second call out starting point for each experiment and hit enter. And I'll get that on my chart. And the last thing I want to do is I want to make a chart title. Okay, so I can click on the little plus box here, chart elements, and just click chart title. Tell it to put above it. And the chart title now that it's highlighted, I'll just say it's equal to this, this cell here. And we have our various parts of our chart all the way done. Now it's just a matter of formatting things to make it look better. Okay, so but we got all the elements off of our spreadsheet. So what I'm going to do is take this chart and I'm going to move it to its own tab. If we go to the design uh, menu bar under chart tool, we'll hit move chart and create a new sheet labeled chart 2. I'll click OK. And here is everything on there. Now it's just a matter of getting it formatted well and want to take a look at doing that. Okay, so let's take a look. We got some very small fonts on here. I'd like to make that a little larger so it's easier to read. I can just single click on vessel temperature for right now. Get that highlighted. Go under home. What I want to do is change the text from, it's a light gray, but I'm going to make it black. And I'm going to select the font to be about 16 points. I'm going to do the same thing for my temperatures. Make them black and make it, we'll also go 16 points. Same thing for my y-axis. 16. And my numbers set at 16. Now I'm going to do the same thing for these callouts. Going to select my data callout. We'll go make it, we can select 12 point if we like. And what I want to do is make that box, instead of having a light gray color, going to change that to click on the format selection, click the little paint bucket and change the color to black. And the width of the line, I'll bring it up to 1. That's fine. And for my font, I want to make sure my text is black there. I'm going to do the same thing for my other call out. Make that black. Turn that into a 12-point font. And my data label, I'll change that to a black here. And increase the thickness of that line. So now I can getting things looking a little better. Just dragging things around. Want to see how things start to look here. So far, so good. I also want to look at, well, what can I do with my data markers? I just right clicked on those. Under the markers, marker options, we'll just increase the size to be about, oh, we can take it up to 9. And the fill, instead of it being a dark color, I'll turn it into white. And the border from blue, turn that to black. Let's see how that looks. That looks nice and pretty there. And my error bars, I'll increase the thickness or the width of them to a value of 1. Okay, so we're getting things looking pretty attractive. Also, I don't want my chart title to be stuck in the middle of my plot, so I'm going to drag the top of my plot down a little bit so my chart title is above it. And I'm going to increase its font size to about 16 points as well. We're almost home. Now I want to do is let's look at my axis lines. Okay, so right now I'm on my vertical axis. I'm going to click on the paint bucket there. And my line, I'm going to change it into a dark color. Okay, make that black. I'm going to leave it at 0.75 point for the moment. I'm going to do the same thing for my x-axis, just make it black. Okay, and then I'm going to go to the little 3-bar axis options. Going to click on the tick marks. And for the major type, I'll click on inside. Notice it put these tick marks inside here now. And the minor type, I'll put also inside. Now, right now our major ticks are at 20 degrees C. The minors are every 4 degrees C. I can change that minor to a value of 10. So there's just not so many of them. And do the same thing for my y-axis. I'm going to put tick marks on the inside and a minor on the inside. Okay, so my major values are 0.1 atmospheres. My minor, I'll change that to 0.05. And now we're almost finished here. Going to just click on the center of my chart. And what I want to do is put the nice border on it. Going to put in a solid border, make that black. And the width I'm going to increase to a value of 1.5. And that gives me a nice border around my plot. And now it's just a matter of tweaking things a little bit. I may want to change my x-axis instead of going from 0. I can go start at a value of 10. And the maximum value, now I'll just put it at 105. So now we have everything properly scaled. Now these error bars, I'd like to pay attention to them, want to explain what they are, but there's no way for me to do a call out like I have for these data points. And so what I'm going to need to do is put in a dialog box, okay? And we can go to the Insert tab and going to click on my chart on the Insert tab under the Shapes. We click on this menu. Look at these. I got callouts available here. So I'm going to click on one of these guys and just draw it right here. And I can grab that little part here and just give it a point like this. Now I don't want it to be filled with uh, a dark color. I can choose a theme style so it's black. And for the text, I can put in an equal sign, say equals, go back to my sheet, and here's my dialogue text, and I'll just put that in there. So I already automatically have my dialog box. I got to stretch it a little bit more, like such. And I can adjust it to wherever I want. And you can tailor it to however you like it. Okay, right now it's at 16 point. Might want to go 12 point like everything else. And continue to play around with it. But the goal is to end up having an attractive looking professional quality graph. And so what we have here is something that um, would be quite acceptable in your classes, and it gives the reader a very good idea of what's going on and convey a lot of information. They know that this line is a ideal gas law prediction. They know that what this each point started off at here, what the error bars are all about, and you got a nice professional quality graph. So there you are. Well done. You can print this out and now put that on the refrigerator because everybody would think that this is a very nice picture. Enjoy.